A one-time password is a password that is valid for only one login session or transaction. OTPs avoid a number of shortcomings that are associated with traditional passwords. The most important shortcoming that is addressed by OTPs is that, in contrast to static passwords, they are not vulnerable to replay attacks. This means that a potential intruder who manages to record an OTP that was already used to log into a service or to conduct a transaction will not be able to abuse it, since it will be no longer valid. On the downside, OTPs are difficult for human beings to memorize. Therefore they require additional technology to work. How OTPs are generated and distributed. OTP generation algorithms typically make use of pseudo-randomness or randomness. This is necessary because otherwise it would be easy to predict future OTPs by observing previous ones. Concrete OTP algorithms vary greatly in their details. Various approaches for the generation of OTPs are listed below, based on time synchronization between the authentication server and the client providing the password, using a mathematical algorithm to generate a new password based on the previous password. Using a mathematical algorithm where the new password is based on a challenge and/or a counter. There are also different ways to make the user aware of the next OTP to use. Some systems use special electronic security tokens that the user carries and that generate OTPs and show them using a small display. Other systems consist of software that runs on the user's mobile phone. Yet other systems generate OTPs on the server side and send them to the user using an out-of-band channel such as SMS messaging. Finally, in some systems, OTPs are printed on paper that the user is required to carry. Methods of generating the OTP. Time-synchronized. A time-synchronized OTP is usually related to a piece of hardware called a security token. It might look like a small calculator or a keychain charm, with an LCD display that shows a number that changes occasionally. Inside the token is an accurate clock that has been synchronized with the clock on the proprietary authentication server. On these OTP systems, time is an important part of the password algorithm, since the generation of new passwords is based on the current time rather than, or in addition to, the previous password or a secret key. This token may be a proprietary device, or a mobile phone or similar mobile device which runs software that is proprietary, freeware, or open source. An example of time-synchronized OTP standard is time-based one-time password algorithm. All of the methods of delivering the OTP below may use time synchronization instead of algorithms. Mathematical algorithms. Each new OTP may be created from the past OTPs used. An example of this type of algorithm, credited to Leslie Lamport, uses a one-way function. The one-time password system works by starting with an initial seed S, then generating passwords F, S, F, F, S, F, 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 S, as many times as necessary. Each password is then dispensed in reverse, with F, 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 S, first, to F, S. If an indefinite series of passwords is wanted, a new seed value can be chosen after the set for S is exhausted. The S-key one-time password system and its derivative OTP are based on Lamport's scheme. An intruder who happens to see a one-time password may have access for one time period or login, but it becomes useless once that period expires. To get the next password in the series from the previous passwords, one needs to find a way of calculating the inverse function far1. Since f was chosen to be one way, this is extremely difficult to do. If f is a cryptographic hash function, which is generally the case, it is a computationally infeasible task. In some mathematical algorithm schemes, it is possible for the user to provide the server with a static key for use as an encryption key, by only sending a one-time password. The use of challenge-response one-time passwords requires a user to provide a response to a challenge. For example, this can be done by inputting the value that the token has generated into the token itself. To avoid duplicates, an additional counter is usually involved, so if one happens to get the same challenge twice, this still results in different one-time passwords. However, the computation does not usually involve the previous one-time password. that is, usually this or another algorithm is used, rather than using both algorithms. The methods of delivering the OTP which are token-based may use either of these types of algorithm instead of time synchronization. Methods of delivering the OTP, text messaging. A common technology used for the delivery of OTPs is text messaging. Because text messaging is a ubiquitous communication channel, being directly available in nearly all mobile handsets and, through text-to-speech conversion, to any mobile or landline telephone, text messaging has a great potential to reach all consumers with a low total cost to implement. However, the cost of text messaging for each OTP may not be acceptable to some users. OTP over text messaging may be encrypted using an A5/X standard, which several hacking groups report can be successfully decrypted within minutes or seconds, or the OTP over SMS might not be encrypted by one service provider at all. In addition to threats from hackers, the mobile phone operator becomes part of the trust chain. In the case of roaming, more than a single mobile phone operator has to be trusted. Anyone using this information may mount a man-in-the-middle attack. In 2011, Google has started offering OTP to mobile and landline phones for all Google accounts. The user can receive the OTP either as a text message or via an automated call using text-to-speech conversion. In case none of the user's registered phones is accessible, the user can even use one of a set of previously generated one-time backup codes as a secondary authorization factor in place of the dynamically generated OTP, after signing in with their account password. Mobile phones. A mobile phone keeps costs low because a large customer base already owns a mobile phone for purposes other than generating OTPs. The computing power and storage required for OTPs is usually insignificant compared to that which modern camera phones and smartphones typically use. Mobile phones additionally support any number of tokens within one installation of the application, allowing a user the ability to authenticate to multiple resources from one device. This solution also provides model-specific applications to the user's mobile phone. However, a cell phone used as a token can be lost, damaged, or stolen. Proprietary tokens. EMV is starting to use a challenge response algorithm for credit cards in Europe. On the other hand, in access control for computer networks, RSA Securities Secured is one example of a time synchronization type of token. Like all tokens, these may be lost, damaged, or stolen. Additionally, there is an inconvenience as batteries die, especially for tokens without a recharging facility or a non-replaceable battery. A variant of the proprietary token was proposed by RSA in 2006 and was described as ubiquitous authentication, in which RSA would partner with manufacturers to add physical Secured chips to devices such as mobile phones. Recently, it has become possible to take the electronic components associated with regular KEF OTP tokens and embed them in a credit card form factor. However, the thinness of the cards, at 0.79 mm to 0.84 mm thick, prevents standard components or batteries from being used. Special polymer-based batteries must be used which have a much lower battery life than coin cells. Semiconductor components must not only be very flat but must minimize power used in standby and when operating. Ubico offers a small USB token with an embedded chip that creates an OTP when a key is pressed and simulates a keyboard to facilitate easily entering a long password. Since it is a USB device, it avoids the inconvenience of battery replacement. A new version of this technology has been developed that embeds a keypad into a payment card of standard size and thickness. The card has an embedded keypad, display, microprocessor and proximity chip. Web-based methods. Authentication as a service providers offer various web-based methods for delivering one-time passwords without the need for tokens. One such method relies on the user unregistered trademark's ability to recognize pre-chosen categories from a randomly generated grid of pictures. When first registering on a website, the user chooses several secret categories of things, such as dogs, cars, boats and flowers. Each time the user logs into the website, they are presented with a randomly generated grid of pixel for numeric character overlaid on it. The user looks for the pictures that fit their pre-chosen categories and enters the associated alphanumeric characters to form a one-time access code. Hard copy. In some countries' online banking, the bank sends to the user a numbered list of OTPs that are printed on paper. Other banks send plastic cards with actual OTPs obscured by a layer that the user has to scratch off to reveal a numbered OTP. For every online transaction, the user is required to enter a specific OTP from that list. Some systems ask for the numbered OTPs sequentially, others pseudo-randomly choose an OTP to be entered. In Germany and many other countries like Austria and Brazil, those OTPs are typically called TANs. Some banks even dispatch such TANs to the user's mobile phone via SMS, in which case they are called MTANs. Comparison of technologies. Comparison of OTP implementations. The cheapest OTP solutions are those that deliver OTPs on paper, and those that generate OTPs on an existing device, without the costs associated with issuing proprietary electronic security tokens and SMS messaging. For systems that rely on electronic tokens, algorithm-based OTP generators must cope with a situation where a token drifts out of sync with its server if the system requires the OTP to be entered by a deadline. This leads to an additional development cost. Time-synchronized systems, on the other hand, avoid this at the expense of having to maintain a clock in the electronic tokens. Whether or not OTPs are time-synchronized is basically irrelevant for the degree of vulnerability, but it avoids a need to re-enter passwords if the server is expecting the last or next code that the token should be having because the server and token have drifted out of sync. Use of an existing mobile device avoids the need to obtain and carry an additional OTP generator. The battery may be recharged. As of 2011, most small card devices do not have rechargeable, or indeed replaceable, batteries. However, most proprietary tokens have tamper-proof features. OTPs versus other methods of securing data. One-time passwords are vulnerable to social engineering attacks in which phishers steal OTPs by tricking customers into providing one or more OTPs that they used in the past. In late 2005, customers of a Swedish bank were tricked into giving up their one-time passwords. In 2006, this type of attack was used on customers of a U.S. bank. Even time-synchronized OTPs are vulnerable to phishing, by two methods. The password may be used as quickly by the attacker as the legitimate user, if the attacker can get the OTP in plaintext quickly enough. The other type of attacker, which may be defeated by OTP systems implementing the hash chain as discussed above. Is for the phisher to use the information gained by this social engineering method to predict what OTP codes will be used in the future. For example, an OTP password generator that is pseudo-random rather than truly random might or might not be able to be compromised, because pseudo-random numbers are often predictable once one has the past OTP codes. An OTP system can only use truly random OTPs if the OTP is generated by the authenticator and transmitted to the user. Otherwise, the OTP must be independently generated by each party, necessitating a repeatable, and therefore merely pseudo-random, algorithm. Although OTPs are in some ways more secure than a static memorized password, users of OTP systems are still vulnerable to man-in-the-middle attacks. OTPs should therefore not be disclosed to any third parties, and using an OTP as one layer in layered security is safer than using OTP alone. One way to implement layered security is to use an OTP in combination with a password that is memorized by the user. An advantage to using layered security is that a single sign-on combined with one master password or password manager becomes safer than using only one layer of security during the sign-on, and thus the inconvenience of password fatigue is avoided if one usually has long sessions with many passwords that would need to be entered mid-session. However, the disadvantage of using many forms of security all at once during a single sign-on is that one has the inconvenience of more security precautions during every login. Even if one is logging in only for a brief usage of the computer to access information or an application that doesn't require as much security as some other top-secret items that computer is used for. See also related technologies, below. Related technologies. More often than not, one-time passwords are an embodiment of two-factor authentication or TFA is a form of layered security where it is unlikely that both layers would be disabled by someone using only one type of attack. Some single sign-on solutions make use of one-time passwords. One-time password technology is often used with a security token. Standardization: many OTP technologies are patented. This makes standardization in this area more difficult, as each company tries to push its own technology. Standards do, however, exist. For example, RFC 1760, RFC 2289, RFC 4226 and RFC 6238. See also, Google Authenticator, Initiative for Open Authentication, KYPS, One-Time PAD, OTPW, AuthShield Multi-Factor Authentication, SKey, Security Token, Two-Factor Authentication, Django One-Time Password, Multi-OTP Open Source a PHP class and a powerful command line utility, OAuth certified. References. External links: RSA Labs OTP Standardization Proposal, Open OTP Solution for Mobile Phones, OTP for Landline and Mobile Phones, How-to and Online Token Generator for Google Authenticator and Apache Mod AUTHN OTP.